All right, welcome back to the third lesson in the trig unit. We are going to be looking at using the trig ratios to solve the missing side. Okay, so the first two lessons we were looking for the primary trig ratios and using the trig ratio to find the missing angle. We are going to use the trig ratios to find the missing side. Okay, now before we do that, we have some um, prior knowledge that we need to recall. So we are trying to solve this equation. Okay, this is cosine 60 equals to x over 10. Now remember, cosine 60, this simply is just a value, right? It's a value, it's just a ratio between the adjacent side and the hypotenuse side of angle theta. So this is just a number, okay? It doesn't look like just a number, but it really is just a number. And that equals to x over 10. So to solve for x, we simply multiply both sides by 10, and that will get rid of that. So then you simply, all you have to do is you go 10 times cosine 60, and you put that into a calculator. That will get you the answer, okay? So cosine 60 times 10 is equal to 5. Okay, so x equals to 5. And you can do the same thing here for part B. Again, tangent 45 is simply just a number. So to solve for x, you just multiply both sides by 15 times 15. So you can get rid of that times 15 here. So x equals 15 times tangent 45. And that gives you exactly 15 because tangent 45 is just 1. Part C is slightly more confusing because the x is in the denominator in this case. But to solve this, what you do is you multiply both sides by x. To get rid of that, then you get x times sine 65 equals 48. And therefore, to solve for x, you then divide both sides by sine 65 degrees. Okay, so 48 divided by sine 65 degrees will give you 50, two decimal places, I guess 15.00 and 5.00, because that's how you should be if you are rounding to two decimal places. And this will be 52, or actually 52, not 5, 52.96. Okay, so that's what x is going to be. Okay, so that's how you solve for x if it's set up that way. And I mean, clearly that's what we're doing today, okay? Last class or last lesson, we learned how to use the primary trig ratios to solve for a missing angle in a right triangle. We can easily extend that knowledge to solve for a missing side in a right triangle. Okay, notice how this is simply just the opposite side over the hypotenuse side, right? So in this case, we know the angle, we know the opposite side, but we are solving for hypotenuse side. Whereas in this case, that's the angle, we don't know the opposite side, but we do know the adjacent side. So we can find the opposite side by setting this up right here. Okay. So let's practice here. It says solve for the missing side, round answers to two decimal places where appropriate. Okay, so here is the triangle. Again, the first step, remember, is to name the side. Here's the angle 18 degrees. There is the opposite side. Here's 90-degree angle. Therefore, that's hypotenuse. And this is the adjacent. So, which ratio should we use? Sine, cosine, or tangent? Well, the side that we're interested in is the opposite side. The side that's given to us is the adjacent side. So, we are going to use opposite and adjacent sides. Okay, so the trig ratio that has both opposite and adjacent is tangent. So we have to use tangent ratio. So tangent of the angle 18 degrees is equal to the opposite side, which is x, over adjacent side, which is 15. Okay, so to solve for x, you simply multiply both sides by 15. So x equals 15 times tangent 18 degrees. You put this into calculator and you would get your answer. 15 tangent 18 degrees. Two decimal places, so 4.87. Okay, I'll let you try part B and see how you do. Okay, so here's the angle, opposite side, 90 degrees, hypotenuse, adjacent. Okay, so hopefully that's what you have. Adjacent, hypotenuse, the ratio we have to use is cosine, right? Adjacent over hypotenuse. So cosine of the angle 56 degrees is equal to adjacent, which is 3, over the hypotenuse of y. Okay, to solve for y, I'll do this one more time. You multiply both sides by y. I think later on you'll see you don't actually need to go through this step, because really to solve for y, you simply divide the 3 with cosine 56. Okay, and then you should get, I have no idea, 5.36. Okay, so that's how you use the trig ratio to solve for the missing side. Okay, I'll let you try this one here. Determine the length of xy to the nearest tenth of a centimeter. Pause the video and give it a try. Okay, so again, here's the angle that's given to us. Let's name the sides: opposite, 90 degrees, therefore hypotenuse, adjacent. Okay, now we are solving for xy, which is this one right here. So we need to find out the opposite side, given that we know the angle and adjacent side. So that is tangent, because O opposite and A adjacent. So tangent of the angle 70 degrees is equal to opposite side, which we don't know, let's just call it x, over adjacent side, which is 5.0. So x equals 5 times tangent 70 degrees. And we put this into calculator. Now, I didn't say this earlier, but we do not need to use the shift or second button because we're not solving for angle, right? So we simply go 5 and then click on tangent, 70 degrees, nearest tenth, so 13.7 centimeter. Okay, don't forget about the unit. It matters. Okay, hopefully now you understand how it works. Now we are going to look at more problems, of course. Okay, so here is first one. It says from a radar station, the angle of elevation of an approaching airplane is 32.5 degrees. The horizontal distance between the plane and the radar station is 35.6 kilometers. Okay, so we got a radar station. Here, radar station. Okay, I don't know how to draw it, so there you go, close enough. And here is the plane. And there is your triangle. Okay, like that. The angle of elevation is 32.5 degrees. The horizontal distance is 35.6 kilometers. How far is the plane from the radar station to the nearest tenth? So we're solving for the hypotenuse, right? That's the radar station and the plane. Well, the top of the radar station, I suppose. Okay, so then, well, again, let's name the sides. Here is the opposite side. Here is the hypotenuse side, and this is the adjacent side. So we are solving for hypotenuse, and we are given the adjacent side. Therefore, we have to use cosine. So cosine 32.5 degrees is equal to adjacent over hypotenuse, again, which I call it the x. Okay. Now, hopefully by now, you can see we can solve for x by dividing 35.6 by cosine of 32.5 degrees. Okay. Whenever the variable is in the denominator, you just need to divide like that. Okay, and now you just need to put this into a calculator. Cosine 32.5. Okay, you should get 42 nearest tenth, so 42.2 kilometers. Okay, I'll show you one more example, and I'll let you try the last one on your own. Okay, hopefully that's not too bad. Okay, so here it says a kite is flown with 210 meters of string. The angle of elevation of the kite is 61 degrees. So here is me, I guess, flying the kite. This is 210 meters. And the angle of elevation is 61 degrees. How high is the kite? Okay, so here is the height we are trying to solve here. Okay. Obviously, it's not really the height above the ground, it's the height above your hand, right, of your arm. And then, I mean, plus, however, whatever the height is between your arm or your hand and the ground. Okay, but that's okay. That's all we need to, that's all we are interested in for now. That's the height. Let's name the sides. Here is the opposite side. Here is the hypotenuse side. Okay, we don't need to even worry about the adjacent side then, because that's what we're just trying to solve. That's what's given. O and H is sine. Okay, so sine of 61 degrees is opposite over hypotenuse. Notice I use H in this case. I don't know. H for height, but it could be confusing, could be hypotenuse. And you can use any variable you want. It doesn't really matter. Okay, so to solve for height, you simply multiply both sides by 210. So 210 times sine 61. Let's see what it gives us. It is 183 nearest tenth, so 183.7 meters. Okay, that's how high above your hand the height is vertically. All right, here is your last example. I want you to try on your own and see how it goes. Okay, pause the video and good luck. Okay, so it says at a horizontal distance of 200 meters from the base of the observation tower. Here's the tower. Horizontal distance is 200. The angle between the ground and the line of sight to the top of the tower is 8 degrees. Again, this diagram clearly is not drawn to scale. That is definitely more than 8 degrees. How high is the tower? So here is the height. Okay, so let's name the sides. That's the opposite side. That's the hypotenuse side. And up here to be the adjacent side. So adjacent, opposite, tangent. Tangent 8 degrees is equal to the opposite side over the adjacent side. So to solve for H, you multiply both sides by 200. Put this into calculator and round to the nearest meter. Tangent 8 is 28 meters. Okay, that is the height of this tower. Okay, so that basically wraps up the trig unit. You know, we look for the primary trig ratios, and we use the ratio to find the angle, and we use the ratio to find the missing side. The next lesson, we're going to be working on multiple triangles, because right now it's just one single one, right? But in a lot of cases, there are more than one triangle involved, okay? Anyways, do some practice, and let me know if you need some help, okay? Good luck.